In this episode, we take the idea of protecting data and turn it into something you can actually run day after day without relying on wishful thinking or perfect user behavior. A lot of beginners understand that sensitive information should not leak, but they picture that goal as a single rule or a single product that magically blocks everything risky. Real environments do not work that way because data lives in many places, moves through many paths, and shows up in surprising formats that people forget to count as data at all. Operationalizing data loss prevention, DLP, means designing a system of controls that can find sensitive data, recognize it in motion, and apply the right handling rules at the moments when leaks usually occur. It also means making those controls dependable in cloud-heavy environments where storage is distributed, collaboration is constant, and data can be duplicated across services in seconds. The goal is not to make data immovable, but to make data movement intentional, visible, and aligned with risk. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A practical DLP architecture begins with an honest definition of what you are trying to prevent, because the word leak can mean many different harms that require different defenses. One type of loss is accidental, like emailing the wrong attachment or copying a file into an unapproved workspace because it is convenient. Another type is negligent, like storing sensitive records in a personal folder because the official repository feels slow or confusing. Another type is malicious, like an insider exporting data to sell it or an attacker exfiltrating data after compromising an account. All three can produce the same outcome, which is sensitive information leaving its intended boundary, but the signals and controls are not identical. This is why operational DLP is both policy and engineering, because you must decide which behaviors are most dangerous and most common in your environment. In cloud security, that decision is especially important because so much sharing is normal and so many workflows involve third parties and remote access. If you define the problem clearly, you can choose enforcement points that make sense instead of spreading yourself thin. Once the goal is clear, the next step is to accept that DLP is really three related problems that must work together: protecting data at rest, protecting data in transit, and discovering where the data actually is. Data at rest is the information sitting in storage, such as databases, file shares, cloud buckets, document repositories, and backups. Data in transit is information moving across networks and services, such as email, messaging, file upload and download, application programming interfaces, and synchronization between cloud platforms. Data discovery is the visibility layer that answers the uncomfortable question of where sensitive information exists today, including places you did not intend it to exist. Beginners often want to start with blocking because blocking feels decisive, but blocking without discovery usually fails because you do not know what you are blocking or where it will pop up next. Discovery without protection is also weak because you learn about risk but do not reduce it. An operational architecture connects discovery to enforcement so the system can adapt as data and workflows evolve. Protecting data at rest starts with storage design, because good architecture makes it easier to apply consistent controls. If sensitive data is scattered across dozens of locations, each with different permissions and retention behaviors, then DLP becomes a constant chase. A more resilient approach is to define approved repositories for sensitive data and make those repositories the easiest place to work, with clear access rules and predictable sharing models. At-rest controls also include encryption, but beginners should remember that encryption is not the same as access control. Encryption helps when storage is misconfigured or physically exposed, but if an attacker logs in as a legitimate user, encryption does not stop them from reading what the user can read. So at-rest DLP relies heavily on permissions, least privilege, and consistent identity enforcement, along with logging that tracks access and bulk movement. In cloud contexts, this means being disciplined about storage policies, minimizing public exposure, and ensuring that sharing features do not silently override your intended boundaries. A common beginner misunderstanding is to think that marking data as sensitive automatically protects it, but labels without enforcement are more like warnings than controls. At rest, DLP becomes real when labels and tags drive concrete behavior, such as restricting external sharing, limiting download to managed devices, or requiring extra approval for bulk export. Another key control is to reduce duplication, because every copy of a sensitive file is another chance for misplacement. That does not mean you forbid collaboration. It means you design collaboration so it happens within controlled spaces where permissions and monitoring apply. It also means being careful with backups and snapshots, because backups can preserve sensitive content long after it is deleted from primary storage. An operational design includes retention and deletion policies that respect sensitivity, and it includes monitoring for unusual access patterns to store data. When these elements are aligned, at-rest protection shifts from a one-time configuration to a maintained posture that stays meaningful as the environment changes. Protecting data in transit is about controlling the common pathways where information leaves one boundary and enters another, because most leaks happen during movement, not during quiet storage. Email remains a classic path, but cloud security introduces many more, such as shared links, cross-tenant collaboration, file sync clients, and automated integration flows that move data between services. An effective DLP architecture identifies the key egress points, meaning the places where data can leave your controlled environment, and then applies policies there. Those policies might block certain sensitive content from being sent externally, warn users and require justification, or allow the transfer only when specific conditions are met. Conditions can include recipient trust, destination domain, device health, or user role. Beginners sometimes think in-transit protection is only about network inspection, but modern cloud traffic can be encrypted and routed through provider services, which shifts enforcement toward application-level controls and identity-based rules. The heart of the design is still the same. You are deciding when movement is allowed and making that decision enforceable. In-transit DLP also benefits from understanding that not all channels are equal in risk and visibility. A controlled corporate email system may support strong policy enforcement and logging, while an unmanaged personal messaging platform may provide little visibility once data enters it. A secure design pushes sensitive workflows into channels that support enforcement and audit, and it limits sensitive data in channels that do not. This is not about being strict for its own sake. It is about aligning risk with control capability. In cloud-heavy environments, users can create links that effectively publish a file to anyone with the link, which can feel like internal sharing but function like public distribution. A mature in-transit strategy treats link sharing as a transfer event that deserves DLP policy, not as a harmless convenience feature. It also considers uploads to third-party services, because those uploads may bypass traditional network controls. When you define these channels clearly, you can apply DLP policies that match how people actually work instead of how you wish they worked. Data discovery is the piece that makes DLP operational rather than theoretical, because discovery reveals the real state of your environment. Sensitive data tends to spread quietly, especially when teams move fast, use multiple collaboration tools, and copy information between systems for convenience. Discovery scans and inventories data stores to identify where sensitive content exists, what type it is, who can access it, and how it is being shared. This is not a one-time activity because data changes constantly, and new repositories appear when teams adopt new tools. Beginners sometimes assume discovery is invasive or purely compliance-driven, but in practice, it is a security control that reduces blind spots. It helps you prioritize, because you can focus controls on the highest risk locations first. It also helps you validate your policies, because you might discover that sensitive data is stored in places where your DLP enforcement does not apply. Discovery turns assumptions into evidence, and evidence is what you need to build policies that actually protect the environment. A key design decision in discovery is choosing how you identify sensitive data, because there is no single perfect method. Some identification relies on patterns, like specific number formats, but patterns can produce false positives and miss sensitive text that does not match a neat template. Some identification relies on labels and tags applied by humans, but humans can forget or misunderstand, especially when they are busy. Some identification relies on context, such as the location of a file, the system it is in, or the workflow that produced it, but context can be misleading when data is copied. Operational discovery often combines these signals, using automated classification as a first pass and human review for ambiguous cases. The architecture should include a safe way to correct misclassification, because misclassification is not a rare error, it is a normal occurrence in large environments. Discovery is also where you learn about data you no longer need to keep, which reduces risk because the safest data is the data you never store. When discovery feeds cleanup and consolidation, DLP becomes a program that reduces exposure over time. To make DLP work as an architecture, you need clear enforcement points that correspond to at-rest and in-transit realities. At-rest enforcement points include storage access controls, sharing settings, download controls, and administrative actions like bulk export and permission changes. In-transit enforcement points include email gateways, upload and download controls, collaboration link creation, and application interfaces where data leaves one service and enters another. In cloud environments, many of these enforcement points live within platform services rather than at a physical network perimeter, which is why identity and policy integration matters so much. A common beginner trap is to focus on one enforcement point, like email, and then be surprised when data leaves through a different route, like a shared link or a third-party integration. The architecture approach is to identify the few high-impact pathways that account for most movement and enforce there first, then expand coverage as you learn. This is also where logging and monitoring are essential, because enforcement without visibility can become brittle and confusing. When enforcement points produce clear audit trails, you can troubleshoot issues and investigate incidents without guesswork. Operationalizing DLP also requires thinking about user experience, because DLP fails quietly when users are pushed into workarounds. If policies block too broadly, users will find alternate channels, such as personal email, screenshots, or copying text into unmonitored systems. That does not mean you avoid blocking. It means you design a graduated response that matches risk and teaches users as it protects data. For lower-risk events, a warning and a reminder of policy might be enough to prevent accidental sharing. For medium-risk events, you might require justification or manager approval, creating a moment of accountability. For high-risk events, blocking may be appropriate, but it should be paired with a clear explanation and a safe alternative path for legitimate needs. Beginners sometimes assume security controls must be harsh to be effective, but in practice, effective controls often combine firmness with clarity. When users understand why a transfer is risky and how to do it safely, compliance improves and the control becomes more reliable. This is especially important in cloud security where collaboration is a core business function, not a special case. Another operational reality is that DLP policies must account for different roles and workflows without becoming an exception factory. Engineers, finance teams, support teams, and executives may handle different kinds of sensitive information, and the same rule may not fit all contexts. If you create too many special exceptions, you lose consistency and introduce gaps that attackers can exploit. If you create one rigid rule, you create friction that encourages bypass. The architecture answer is to use classification and context to drive policy, so the rule is stable but the decision adapts. For example, sensitive data might be shareable within a defined group but blocked from external destinations, while less sensitive data might allow broader sharing with logging. You also need ownership and review for exceptions so they do not accumulate permanently. In cloud environments, this often means aligning policies with identity groups and approved collaboration boundaries, rather than treating every external recipient as equally risky. When DLP is aligned with real workflows, it becomes a guardrail that guides behavior rather than an obstacle that people fight. A serious beginner misunderstanding is to treat DLP as purely a prevention tool and ignore its detection value. But detection is often where DLP provides the most immediate security benefit. Many organizations cannot block every risky transfer without breaking business, but they can monitor and alert on high-risk patterns. Examples include repeated attempts to move sensitive data, unusual bulk downloads, sudden changes in sharing settings, or sensitive uploads to unfamiliar destinations. These signals can indicate insider risk, compromised accounts, or misconfigured integrations. When DLP is integrated with monitoring, you can escalate concerns quickly and contain issues before they become breaches. Detection also helps tune policies, because you learn which rules are too noisy and which real risks are slipping through. For cloud security, where data movement can be fast and distributed, detection is essential for timely response. An operational DLP program treats prevention and detection as a paired strategy. Prevent what you can confidently prevent and detect what you cannot confidently prevent without harming business operations. Retesting and continuous improvement are part of operational DLP because the environment changes, and every change can create new leak paths. New cloud services are adopted, new integrations are built, and new collaboration patterns emerge, often faster than policy can keep up. If you do not revisit DLP coverage, you end up protecting yesterday's pathways while today's data moves through unmonitored routes. Operational DLP includes periodic discovery scans, periodic reviews of policy effectiveness, and drills where you validate that enforcement points behave as expected. It also includes reviewing false positives and false negatives, because both are expensive in different ways. False positives create friction and reduce trust in the system, while false negatives create silent exposure and delayed incident discovery. Beginners should understand that DLP is not a set-it-and-forget-it control, because it is tied to human behavior and evolving technology. When you treat DLP as a living system, you maintain alignment between policy intent and real-world data movement, which is what makes the control reliable over time. To synthesize everything, operationalizing DLP architecture is about building a coherent set of capabilities that cover data where it sits, data while it moves, and data you did not even realize you had. At-rest protections rely on disciplined storage design, strong identity-based access, and consistent handling rules that reduce duplication and control sharing. In-transit protections rely on identifying egress points and enforcing policies in the channels people actually use, especially in cloud environments where collaboration and integration are constant. Data discovery provides the visibility that makes the entire strategy grounded in reality, guiding prioritization, cleanup, and policy tuning. A mature program balances enforcement with usability, so users do not bypass controls, and it treats detection as a first-class outcome so incidents can be caught early. When these pieces reinforce each other, DLP becomes less like a fence you keep patching and more like an operating posture that steadily reduces risk while allowing legitimate work to continue. That is the mindset SecurityX expects. Build controls as systems, place them where they matter, and keep them working as the environment evolves.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.